Of what abilities, attributes, effects, events, and tags are and how to use them. Let's start by creating a brand new project using the first person template. The first thing we need to do is enable the gameplay ability system by opening the plugins tab and searching for gameplay abilities. Every actor in your game that needs to use the gameplay ability system needs to have an ability system component. So let's open up the first person character blueprint and add that component. In this template, when you pick up the weapon and try to shoot it, it spawns some projectiles. What we're going to do first is turn that into a gameplay ability and then go from there. So when you touch the gun, this component gets attached to your player and it essentially adds the functionality to shoot the gun. All we need to do is move this code into an ability. So let's just create a new blueprint and select the gameplay ability as the parent class. Now let's go back to the shooting component and copy the shooting logic into our new ability. Now, of course, if we try compiling, we will run into tons of errors due to missing references, so let's just go ahead and fix those real quick. To get a reference to the character that's casting the ability, we can use the node getAvatarActor from ActorInfo. With a reference to the actor, we can cast it to a player and fix all of the broken references. Now the last thing we need to add is the end ability node. If we don't end the ability system will think that the ability is still trying to do things and it's not going to be able to activate again. Now that we completed our ability, let's go back to our player character blueprint and give that ability to our ability system component. This will allow us to actually activate the ability whenever we need to. Now let's go back to our weapon component and replace all of the old code with our ability activation. Ability activation can be blocked by cooldowns, costs, or other gameplay effects, which is why the node is called try activate ability, and the output will indicate whether or not the ability activation succeeded. There are different ways to activate abilities, but let's just pick activate by class because it's the simplest one for now. Let's compile, save, and run just to verify that the gun works just as it did before. And I can remove this link just to confirm that it is in fact driving the shooting mechanic. Gameplay tags are essentially just labels that you can attach to actors, gameplay effects, and abilities. To view them, open your project settings and go to the gameplay tags panel. Now if you click manage gameplay tags, you'll see that there are already some gameplay tags created for you. Let's go ahead and create a new one, and this one will be to activate our primary ability for our rifle. I'm going to use a general name and call it weapon.primary because if I were to create other weapons, I could use this same tag and simply determine which ability to activate by granting or removing their relevant abilities. To add this tag to our ability, let's open up our ability blueprint and click on class defaults. On the right, you'll see a list of tag containers. The first tag container contains all of the tags for the ability itself. The rest of them contain tags for rules on how the ability should behave. So to add our tag, let's open the dropdown and select the weapon.primary tag we created. To keep this tutorial simple, I'm going to skip the other tag containers, but if you're interested, definitely leave a comment down below and I'd be happy to explain those as well. Now that we have our ability tagged, we can actually activate it by that tag instead of by the specific class. This is my preferred way of doing it because it allows you to swap out abilities from other systems and leave the code activating the abilities completely unchanged. Let's compile and run and verify that we can still shoot as we did before. Gameplay effects are probably the most powerful aspect of this whole system because they can modify attributes, grant and activate abilities, add and remove gameplay tags, etc. First, let's create a new tag for our on fire effect that we're going to create. With our tag now created, let's go back to our content browser and create a new gameplay effect by creating a new blueprint and selecting gameplay effect as the parent class. We basically want this effect to look like the target is on fire and we want it to deal damage over time. So first, let's give this effect a duration. Effects can be infinite or have durations that scale based off of attributes or other things, but to keep it simple, I'm just going to hard code in a value for the duration. Gameplay effects don't actually have blueprint functionality. Instead, you control its behavior through components, modifiers, and executions. To mark the target as on fire, let's go ahead and add a component of type target tags gameplay effect component. This is what actually grants the tags to the actor that has the gameplay effect, and then we'll select the tag on fire that we created. If we want our ability to stack, you can go down to the stacking category and select the stacking type, but for this tutorial, we'll keep it disabled. Now that we have our effect, let's learn how to apply it by updating our projectile blueprint to apply the on fire effect to any targets that it hits. Let's first open up the projectile blueprint and edit the on hit event. We want to actually move the destroy actor node to the end of a sequence and add another step to that sequence to actually apply the effect to any hit actor. So as I said, any actor that wants to use the ability system must have an ability system component. So we'll want to get the actor's ability system component and make sure that it's valid, because an actor might not have an ability system component. Once we verify that it is valid, we can actually try applying that effect to the hit actor. Now there is a difference between applying self versus applying to target. For now, I'll just keep it simple and apply to self, and I will select the gameplay effect class that we created. There are more advanced things you can do with gameplay effects using levels, effect contexts, and effect specs, but I'm gonna just keep this tutorial as simple as possible and leave the effect context as empty. To make sure that our effect is getting applied, I'll just print a string once it is applied. Now if we try hitting play and shooting a cube, you'll notice that nothing is getting printed. That's because the cube does not have an ability system component. So I'm going to quickly create a new actor with a cube mesh, the ability system component, and simulate physics ticked on. Let's drag a few into the scene and try shooting them. As you can see in the top left, our print statement is printing, which means our effect is being applied. However, there is no visual indicator that our cubes are on fire. That's where gameplay cues come in. Gameplay cues are essentially auditory and visual cues that get automatically added to a scene whenever its associated gameplay effect is applied to something. Let's create a new blueprint class and set the gameplay cue notify actor as the parent class. Next, add a Niagara particle system component, and let's just go ahead and create a really simple particle system. Each gameplay cue needs its own unique gameplay cue tag, so open your class defaults panel and set the tag for this gameplay cue. This tag is used to link our gameplay effect to this cue. So if we open up our gameplay effect class and to add the gameplay cue tag that we just created to that list. This will ensure that the effect will then spawn the gameplay cue whenever it is applied. You can make cues scale off of magnitude and effect levels, but again, we'll just skip that for now. Now if we hit play and try shooting the cue, we'll notice that the cue does get spawned in, but it's not attached to our actor. That is a very simple fix. You simply go to your cue, open class defaults, and toggle auto attach to owner. Let's also toggle auto destroy on remove. Now if we hit play and try shooting the cube, we'll notice that it's actually attached and gets automatically destroyed when the effect ends. As their name suggests, gameplay attributes are essentially just float values that are stored on gameplay ability system components to keep track of things like health, mana, stamina, etc. If we want our abilities and effects to modify these attributes, we need to first define them in an attribute set. Attribute sets can only be defined in C++ right now, so we'll need to create a new C++ class with attribute set as the parent class. I'm just going to call this my character attribute set, and I'll open it up in my IDE. We're going to keep this very simple and delete the declaration file, keeping only the header file. Next, we can just copy paste some code from the guide on my right. I'll leave a link in the description below. The first code snippet we'll copy just to find some macros that every attribute set needs. And the next code snippet defines the actual attributes on your attribute set. You can pretty much just copy paste this for all the attributes that you think you'll need for your character. But since we just created our C++ project, we need to add the ability system component header file as well as the gameplay abilities module to your project. Once you recompile and run the editor, you'll be able to create a new data table, and we'll make the row structure attribute metadata. Now to initialize each attribute, you'll need to add the name of your attribute set as the first part of the name without the U, dot, and then the name of the actual attribute, so in this case health. And for the base value, we'll just give it a value of 100. Now that we have a data table that initializes our attributes, we'll want to go back to our player character, click on the ability system component, and look for default starting data, add an entry, select the attribute set, and then the data table we created with all of the default values. Because we want cubes to also take damage, we'll want to initialize their attributes as well. Now that our characters have attribute sets defined and initialized, we can go back to our on-fire gameplay effect and add a modifier. This modifier will add a negative value to the health attribute. We also want the effect to deal damage every 0.25 seconds, so all you have to do is modify the period and set that to 0.25. To make sure that our effect is dealing damage, let's just make the cube print out its current health every tick. And to get an attribute value, you would use the get gameplay attribute value node that comes from the ability system component. Alright, so if we hit play and shoot a cube, we'll see that the effect is dealing damage every 0.25 seconds. However, the health is actually dipping into the negatives. Fortunately, attribute sets have a ton of functions that you can override to give you better control over how attributes and effects interact. I would solve the negative health problem by overriding the pre-attribute change function and simply clamping the new health value from 0 to 100, and then overriding the health attribute to be that new clamped value. This is starting to get into more advanced territory, so if you'd like to learn more about all the different functions that you can override in attribute sets, definitely leave a comment down below, but for now, we're going to move on. Gameplay events are essentially just messages that you can send to and from actors, specifically that have ability system components. And I mention that because these events can actually trigger gameplay abilities and can also be weighted on from gameplay abilities. To demonstrate, I will simply update the projectile blueprint class to send a gameplay event to the player whenever it hits something. And to tell it which thing it actually hit, I can make a gameplay event data struct and pass in the target. To demonstrate, let's go back to the player blueprint and wait for that event and simply print out a string whenever it's received. And for the final demonstration, I will create a new gameplay ability that will get triggered by this event. And to trigger it, edit the class defaults for that ability, scroll down to ability triggers, and add the tag for the event that you're sending. Don't forget that we need to give the player this new ability, and now if we play, we can verify that the ability is getting triggered when the event is detected. Well, that's it for this video. If you found it helpful, please consider leaving a like and subscribing. And as always, don't hesitate to leave a comment on what you think I should cover next. I am just starting to make content again, so I'd definitely love to hear any ideas you guys might have.